So, hello everyone, welcome to the presentation. And as you already know, this presentation is going to be about gesture recognition. And the first part of the presentation is going to be about our platform, technologies we use, and something about us. And the second part is going to be about a framework we use for detecting gestures. And at the end of the presentation, you will see some demo video showcase. All right, so my name is Vladimír Demčák, and I'm in Accenture for more than 4 years. And my official position is technology architect specialist. And I work with technologies like Java, big data, Hadoop, Hive, or Kafka. And recently, I started working on AI modules. I will talk about that in a minute. And I work on a platform which is called VASP, and it is acronym for Video Analytics Service Platform. Tomáš is my colleague, so Tomáš, you can continue and introduce yourself.
Yes, thank you. So, as Vladimír mentioned, we are working together at the same project. I have been in Accenture also for 4 years, and I have learned plenty of things about Docker or cloud or Kubernetes and big data and video analytics. So the first and most important question is, what is video analytics? Basically, you take some video stream or stream from camera or from some file or just some picture, and you will analyze what's on that picture or on that specific frame. So we will know that, for example, there are 2 people and 1 car, but this information is useless. You need to put this information in some context. So you take multiple frames and analyze them one after each other. And then you will know that, okay, there is a parking lot, and there is 1 person walking around the car. He looks nervous. So maybe he might be trying to steal that car. So let's notify some security or police. Or someone left some baggage at the airport. It's there for 10 minutes. It can be bomb or something dangerous. Let's notify the security. And what we are trying to do on our project is to connect the video analytics with business processes. For example, you can have amusement park where you have some cart or roller coaster, and first it needs to start, then the gates need to open, the people need to leave, and only then the new people can enter the vehicle and start the new ride. So basically this is some process, and in this process there are a few actions. And every action needs to be done in specific and correct order. So you can have tens or hundreds of people watching every area and telling, okay, this process was done correctly, you can start. Or you can have one video analytics system, and you will just connect all the cameras to it, and it will do it for you. So you don't have to pay for hundreds of people, and people make mistakes because they can be tired or they don't like their job. And we have project in Bratislava that consists of 9 people. You are trying to use all the new technologies that can be good for us or for the client. So we are trying to be innovative. And we have done multiple proof of concepts and pilot worldwide. We had clients from Singapore or United States or Finland, Brazil. And basically, when you are doing video analytics, you have plenty of data that you need to analyze. So we are also working with big data. Now I will tell you some milestones of our project. So we started working with this project in March 2016. And the first big milestone is that we started using the AI models with TensorFlow, and we were able to detect any kind of object that we needed. And this allows us to use the GPU acceleration with NVIDIA. The next milestone was a proof of concept for all company, where we use this technology. Then we created Map UI, and we have client in Singapore, and we created for this client like smart city. And there were multiple agents. We can call it agent. It was ambulances or police cars, and they have video cameras attached to them. So we were able to connect to these cameras and do the video analytics. We were also able to see these agents on the map, and we have basically smart city. Then we have amusement park proof of concept, where we use this connection between video analytics and business processes. And then we created like smart city for city of Brazil, and we connected the waste data to our video analytics platform. So basically we were able to see the detections and some business logic on the map, and also the waste data. For example, there is some traffic jam and there are 20 cars with this license plate waiting to move on. And the next milestone was gesture recognition. Then what we started using, Vladimir will tell you something more about it, and we created XR demo in our office. And currently we are working on the FPGA acceleration, and we are trying to, or we are already using the Raspberry Pi as some edge device. So basically we connect this FPGA stick into Raspberry Pi, and it's doing the detections on Raspberry Pi and sending it to, for example, to cloud or on-premise. And the technologies that we are using is, for example, OpenVINO or OpenCV to be able to emulate the human vision. And we are also using NVIDIA CUDA for parallel computing on NVIDIA GPU cards, or TensorFlow, which allows us to use the machine learning. What's really important is that we are using Docker. That means that every component that we use is some Docker image. This allows us to take these Docker images for the specific client and put them together and deploy it. For example, he doesn't need like 20 components, just 10 that we already have. We connect them together, create some new components for that specific client, and we are able to deploy it on cloud. We are able to deploy it on AWS, Azure, Google Cloud, basically any cloud provider. And we are also able to deploy it on premise. So we are agnostic about the background technology. And the cool feature about this is that we already have multiple components created. So many clients think that video analytics and the deployment of video analytics took like years, but because of this, we are able to deploy in terms of weeks or months, maybe, the working proof of concept for a specific client. We are also using the Hadoop and Apache Hive to store the big data and analyze them, or Apache Zookeeper to store the configuration for our components, and Kafka as a publish subscribe streaming hub. And we are using Spark to analyze the streaming data. And we are using also Erango to save the infrastructure for map UI and the detections. And also we are able to scale our solution using Kubernetes. So someone might ask, why should I use video analytics when I have my Kinect? That's a good question, but because Kinect has some cool features like full body 3D motion capture with the depth sensor. It has some infrared sensor, and it can be working in any light conditions, which is pretty cool. But it has a limited range of and field of view, so you need to stand at some specific place for it to work. It has also ability to get the position and orientation of 25 joints at the body, which is very nice feature, and it can do the facial recognition. But with video analytics, you can detect any kind of object, face, gestures, emotions, demographics, or license plates, and you can run it, as I said, on the cloud, on premise, on Raspberry Pi, and you can use any type of camera. Basically, you just need to connect to that camera and you are able to do the video analytics. And you can use also the GPU or FPGA acceleration, which is much, much faster than the CPU. And we are using the convolutional neural networks, so we are still improving our trained models. It's also good to mention the difference between voice assistant and gesture assistant. Basically, for voice assistant, you need to have your microphone turned on, and you can be afraid that someone is listening to you, for example, some bad comparison. And with gesture assistant, you need to have the camera turned on, and you can cover it if you are afraid. A voice assistant is good for the handicapped people. They can use only their voice and get the functions they need. But there is the risk of revealing information. You cannot talk about some secret information on the street with all the people around, and almost always you need to be online to get some information from Alexa, for example. But you have the unlimited options. You can train your voice assistant to do basically anything. But it's language specific. So you are speaking with some language that only 9 people use. It's less probable that you will have this voice assistant for your language. And with gesture assistant, the gestures are universal language, and it can be much faster. The privacy is higher because you can create your own gestures, for example, or use your thumbs and so. And it's mute friendly. If you have problems with your voice, you can use only the gestures. And the idea that Accenture is trying to push forward is that AI is the new UI. So basically, AI can serve you as creator, advisor, and orchestrator. The creator is, for example, Spotify. It can tell you that, okay, you have been listening to these heavy metal bands. Try this one. It can be good for you. And advisor is, for example, it can tell you that, okay, on Friday morning you are running 10 kilometers to the work, but today it's going to rain, so just run 5 kilometers and then use public transportation. And the orchestrator is, for example, some intelligent home. When you are waking up, it will turn on the temperature for some specific degree and play some music for you. And the accuracy in speech recognition is 94.1%, which is pretty nice. And the latency used to be 3 seconds for speech recognition. Now it's only 1.5, which is much better. And the error rate for computer vision is human-like. And all these variables are still improving, so it will be better and better in time. And AI can also serve as some conversational interface between the client and businesses, and it can give you the real-time suggestion for your needs. And now Vladimir will tell you something more about the technical stuff and the gesture recognitions.
Yeah. All right. Thank you, Tomáš. So now we're gonna talk something about OpenVino, and maybe we can start with a question. If you have ever heard about OpenVino, just raise your hand. Okay, one guy. And do you know what CUDA is? Okay. So if you know what CUDA means to NVIDIA, you should already know what OpenVino means to Intel. And before we starting talking about capabilities, let's talk something about releases. And Intel, which is developing OpenVino, they usually have 4 releases per year. And now we have released R3, and until the end of the year, we should get the R4 release. And they used to add a lot of new things into the toolkit. So if you want to keep your application up to date, you need to really deal with that. And now let's talk something about capabilities. So OpenVino is able to run your code on different hardware. And with that said, we are able to accelerate our code on these devices. The second capability is something which is called DLDT, and it is a shortcut for deep learning deployment toolkit. And this means that you can, for example, have a TensorFlow model or Caffe model, and with Model Optimizer, which is included in OpenVino, you can convert the models into OpenVino models, which are suitable and runnable on Intel's devices. And the last capability I would like to mention here is traditional computer vision. So OpenVino has already built in OpenCV or OpenVX, and you can use it. But as you probably know, Intel is not focused just on software, but on hardware as well. And they are focused on edge computing, and they have created a lot of fancy devices. So for example, here, the Movidius compute stick, it is here. It's a very small device. You can just take and plug in into, for example, Raspberry Pi, and you have a device for edge computing. You have quite good performance, and it is low power consumption device. And in this one device, we have something which is called Myriad X chip. And thanks to this chip, we are able to run a neural network and AI stuff on this device. All right, and they have created another cool device, which is called Mustang V100 MX8. And the suffix MX8 means that on this device we have 8 Myriad X chips. So the performance should be similar to 8 Movidius USB sticks. And what is important for today's presentation is this device. It's called Mustang F100A10, and we call it FPGA. And that's basically everything about hardware. And now we're gonna show what is OpenVINO Toolkit in terms of processing video stream. So basically this picture is showing everything what we need to know in terms of processing video stream. And here we have 3 steps: pre-processing, inference engine, and post-processing. The pre-processing is basically converting video into some digital form. For this we need some decoder. And once we have decoded video stream, we can process the frame and prepare the frame for inference engine with, for example, OpenCV or OpenVX. And now inference engine. This means that we can run our neural network. We can have different model, and we can run it on, for example, CPU, GPU, VPU, or FPGA. And the device returns results, and we can post-process the results. And with that said, we can use OpenCV for example, drawing bounding boxes over the picture. We can draw some overlays over that, and we can expose the results to the outside world with encoding and exposing via, for example, MJPEG video stream. All right, but we are developers, right? And we do care how it looks from code perspective. So now we are going to use OpenVINO Python API, because pretty much every module we have in VASP is built on Python and implemented in Python. So everything what we need to import from OpenVINO Inference Engine is Inference Engine Network and Inference Engine plugin. And now we need to create a plugin. With that said, we need to specify on which device we are going to run our neural network. It's usually some input at the startup of the application. We have a plugin, and now we need to say on which model we are going to use for processing video stream. And the Inference Engine Network constructor has 2 parameters. The first one is binary model, the path to binary model, and the second parameter is XML file, again, the path to the XML file, which is basically some kind of metadata, or this XML file is describing the model. And we have some helper variables for post-processing the results from Inference Engine. And it's pretty much everything what we need. Now we need to create some interface between us, between our code and the device. And it is done by load function, and we have execution network. And we can do inference, and the inference call returns results. And now we just need to post-process the results. Is usually some array, and now we need to iterate over the array and map the results into some business entities. So for example, here we have object detected business entity, and we want to process bounding boxes, classification, and confidence. And it's pretty much everything what we need to know in terms of how to implement OpenVINO. All right, and before we start talking about pre-trained models, as I said, there is something which is called DLDT, and we can create our custom models. So for example, here, during one of our project, we needed to create a model which is able to detect if a person is wearing helmet or vest, or both helmet and vest, as well as boxes. So we were able to do this with OpenVINO and pre-trained model. text detection and text recognition. So with the pre-trained model, we are able to read what is in a picture. Again, face detection, we are able to detect the face, and not just the face, but we can detect where is a person looking at, which is quite cool. And another cool pre-trained model is segmentation. So we don't get bounding boxes from the model, but real areas, and we know where is a vehicle or person or bicycle. And recently they have added action detection. So you are able to detect if a person is drinking or eating during a ride, which is quite a dangerous situation. But what is the most important for today is something which is called pose estimation model. And let's talk something about this pose estimation. The official name of this model is Human Pose Estimation 0001, and it's built on OpenPose. And OpenPose is quite a popular model. By the way, if you know what COCO dataset means, they have won competition focused on key points. So key points competition in 2016, so quite good model. But Intel decided to create their own model because they wanted to use the model on edge computing. And the model is able to detect 18 key points. So, for example, ears, nose, shoulders, wrists, knees, and hips, for example. And maybe you can ask, how can I get this model? You don't need to go to some web page and download binary and XML file. You just need to use their script, downloader script. So once you have installed your OpenVINO, you have this Python script already there. And you need just to specify which model you need to download. Here we are saying that we want to download human pose estimation, and that's it. We have a model. And they have a lot of already implemented samples, usually in a C++ API. And since we have Python and everything we have in terms of AI is implemented in a Python, we had basically two options: to rewrite the whole application written in C++ into Python, or create a wrapper over the C++ application. And as I said, it's quite challenging to keep the application up to date because OpenVINO is changing very fast. So we have decided to go for option number 2. So we have created a wrapper, implemented in Python, and everything from loading a model, calling inference engine is happening here in C++. And in our Python application, we just take the results from C++ application and do the post-processing, like mapping the results into business entities. All right, and maybe you remember this guy if you attended OpenSlava the last year, the previous year. By the way, our presentation or our approach doesn't have anything with his presentation, where he was doing some magic stuff with drones and hands. But we wanted to show you how it looks like from a computer vision perspective. And we cannot use some movie clip because of copyrights, right? So it looks like this. And today, we are going to show you a recorded video. We have recorded last week, and it was recorded on this device. You can see on the table. And this device is called Mustang, it is called Tank 870, and it is AWS qualified device for Internet of Things. And inside this full-featured computer, full-featured machine is Mustang F100. And when we were working on one of our projects, when we needed to detect poses and gestures, we were struggling how to name certain poses. So it's pretty challenging to have common and unique name for different pose. And we have decided to use something which is called alphabet semaphore codes. Maybe it looks familiar to you. And each of these code represents different letter. So for example, O, P, E, etc. But what is, and we are going to use the alphabet semaphore for the demo at the end of the presentation. But what is more important in real life is something which is called ACL, Sign Language, American Sign Language. But it's completely different story. But we would like to, we wanted to show you that something like ACL exists. All right, and today's demo is going to be about controlling devices, controlling things. And those two things will be two lights, the light on desk and ceiling light, like here. It will be completely virtual environment. And if we want to switch from one screen to another screen, we need to do some gesture or some pose. And so, for example, if we want to go to home page, we need just to do uniform. If we want to switch to desk light, we need to do foxtrot. With Bravo, with the right hand, we will switch to ceiling light. And for switching the lights on and off, we will just raise left hand and the lights should turn on or turn off. But again, how it looks from code perspective. This is implemented in a Java because you will see the module which is dealing with business logic is implemented in Java, and it's pretty much very simple logic behind it. So we need just to validate if we have all key points needed for further processing. So after validation, we just compare positions of key points. So for example, we need to validate for foxtrot, we need to validate if left wrist is being detected, if left elbow and right shoulder is being detected. And after that, we just compare if they are horizontal, if, for example, left elbow is horizontally in between left wrist and right shoulder. And it's pretty much same for Bravo, for the right hand, and for Echo, again, the same logic for uniform. But maybe you can ask how it looks like from architecture point of view, how the data flows looks like. So we have a device. This device is camera basically, and this camera is producing stream. This stream is being consumed by something which is called source, and it's a Docker container. As Tomáš mentioned, everything what we have, we are trying to have in Docker image. And the source is splitting the stream, and the source is sending frames into Redis, which is very, very fast key value storage. And OpenVINO, the detector, is consuming frames from Redis and doing the analysis. And based on the Inference engine results, we have poses, and poses are being sent into message broker, into Kafka, again in a Docker container. And the indicator business rule we have shown in the previous slide. The foxtrot, uniform, and Bravo, for example, is happening here. So in this model is happening all the aggregation, filtering, etc. And it is sending the messages into flow. And flow is basically our stateful place where we have a BPM and process. And we have also database here. And flow exposes SSE endpoint, and it is the endpoint is being consumed by UI. And this is pretty much everything from architecture and data flow perspective. And here we have a sample how BPMN or how state diagram looks like. Basically, we have three branches, and on each of those branches is some kind of waiter, and the waiter is waiting for signal, for example, Foxtrot, or for example, Bravo, and cancel process as well. And the system tasks like desk lamp, overhead lamp, or cancel process, they send the message to UI via SSE endpoint. And again, echo signals and toggle messages. And before we are going to show you the video, the demo, we would like to talk something about what is next or what we would like to do in the future. And as I said, or as I mentioned, OpenPose, in 2019, this year, they are further than they were in 2016, and they are able to detect more key points, especially the fingers. And we didn't mention sign language for no reason. So in the future, we would like to, or it would be great to have some kind of translator from sign language into speech or text, especially in a real time. And there is also demand in sport area. For example, VAR, maybe some of you know what VAR means. It's a video assistant referee, and it is used by referee, soccer referee, for deciding if there was goal or no goal, penalty, no penalty. And we think that with video analytics, we can help them. And also we can have some kind of virtual trainer, and this trainer can count how many push-ups or squats you have done. And yeah, we know that AI or video analytics is not 100% correct. It's not perfect, but we don't want to replace humans with video analytic, but we want to help human to make decision faster and react quicker on certain unclear situations. And now the demo. So as you can see, the person will stand in front of the camera and raise the left hand, doing the foxtrot and the echo for switching on and switching off the light. And if the person wants to go back to home page, the person has to do uniform. So here we have a home page again for another screen, the right hand of Bravo, and again switching between everything is done via pose estimation detector. And that's pretty much everything we wanted to show you today. And if you have any questions or any kind of ideas how to improve or make this gesture assistant better, just stop by or raise your hand and say what you want. So basically, thank you for your attention. Hope you enjoyed it. And now, if you have questions.
During your presentation, you have mentioned Microsoft Kinect. Can you use it commercially?
Maybe this question is better for Tomáš.
That's a very good question. I'm not sure, but there should be some licenses and so, but we have never used it commercially, so I don't know.
We just wanted to show you basically the differences between Kinect and Video Assistant.
Thank you.
You're welcome.
There is one question.
Eddie back. Back.
So you showed us some external USB stick and some beefy machine that does all the calculations and so on. And my question is, how demanding is this for processing power? I mean, can I maybe run this on like standard ARM processor, maybe on my mobile phone or something without need of this beefy machine, or sending all the stuff to somewhere to the cloud? And how is this in terms of performance demanding and so on?
All right, so OpenVINO is able to run on various OS, so you can run it on Windows or Linux, for example. And for example, this small device is, I think, designed for small devices like Raspberry Pi or Arduino or something like that. And it's pretty much small. It doesn't have a performance like FPGA or VPU, but it's quite good if you don't need to process, if you don't need to have 24 FPS, just 10 or something like that. And I think you don't need quite great performance. You just have like I don't know what kind of CPU is on a Raspberry Pi, but it shouldn't take a lot of power. And those devices are designed for edge computing, as I said. So they are designed to be to have high power or high performance and low power consuming, or this kind of.
It possibly can be viable to run it maybe on Raspberry Pi or whatever.
Yeah, definitely.
Possibly.
On Raspberry Pi, definitely. We tried and we played with that. But not sure about what did you say about mobile devices or something like that?
So maybe on my mobile phone, yeah,
I'm not sure.
Android, iOS.
I don't know if OpenVINO is able to run on mobile devices.
I see.
Okay.
Thanks.
Okay, I think there are no more questions. So thank you for your attention and enjoy the rest of the OpenSlava.
Yeah. Thank you.